Hello, everyone, and welcome to the fifth Operate First Data Science Community Meetup. And today we have Shrey, who's going to be talking about how to use the Open Data Hub services on the Operate First infrastructure to create an end-to-end inference pipeline for the NLP inference model. So let's get started. And before we get started, if there are any questions about why we are conducting this meetup or any suggestions or feedback, please use this time to suggest anything. And after this, Shrey, you can go ahead and start with your presentation.
Great, thanks, Akanksha. If there are no questions, I can go ahead and present my screen. Okay. Screen all good?
Yes.
All right. Okay, hi everyone. I'm Shrey Anand. I'm a data scientist with the Open Services Group at Red Hat. And today we are going to look at how to use Open Data Hub services to create an inference pipeline. And this inference pipeline is for a natural language processing model developed in the OS-Climate community. So the project is being developed by the Open Services Group and the OS-Climate community. And by the end of this talk, hopefully you'll have some idea of how to convert your ML notebook into a more reproducible and automated pipeline so that you can use it multiple times in different environments. So I'll start with some context to why we are interested in this and also the open source environments that are involved in this project. Then we'll move on to the environment setup or talk about how we can make our ML workflow actually reproducible in different environments. And then finally, we'll talk about the NLP notebooks and the results that we get from implementing this model. So a little bit about the OS-Climate community. It's an open source collaboration community to build data and analytics software platform supporting global investments into climate change mitigation and resilience. So in other words, until now, asset management and investments in the financial industry just looked at the risk reward, but there has to be some consideration of impact to the environment as well. So to help resource allocators choose environment-friendly options, there are efforts to score different businesses based on how they impact the environment. So, and when you're making such decisions where you are basically scoring different businesses, you have to get data from a like a variety of sources, such as energy emissions or the market or like the corporate hierarchies and identities. So the overarching aim of the community is to make this data available and usable for prediction and decision making. So if you're interested more in like the overall goals of the community, you can watch the keynote by Michael Tiemann, Marcel Hild, and Eric Ellenson for DEF CON CZ 2022. That's linked in the slides. Here we are, in this project, we are going to work with one of the aspects of making this huge data available and in a standardized format. So what's the exact problem that we are working with? So the companies or businesses have climate reports where they talk about their climate commitments and carbon emissions. And they have these reports in a PDF format where they don't really follow any standard. So manually reading this PDF to find information and questions answers to questions that we're interested in is a difficult task. And also, if you have PDFs from hundreds of companies, then there has to be some automated way of going through these PDFs and getting the information that you need about that company. So that's precisely what we are working with. The solution here is an NLP model that was developed by the Allianz group in the OS-Climate community. And this model precisely works on this task. It takes PDFs of climate reports from different companies and find answers to questions that we're interested in. So what we in the open services group are trying to do is take that NLP model and using tools provided by Operate First and ODH, convert it into a more reproducible and consumable format. So let's say any developer wants to contribute and they want to run the NLP models on their system. They should have an easy way of running the entire experiment and then contributing to it. So just to quickly summarize what Operate First and ODH services are. Operate First is an initiative to bring operations and its vast knowledge in the open source community. So this enables us to quickly spin up clusters on OpenShift, like we did in this case, and the cluster for OS-Climate is called OSC. And once we have the cluster up, we can deploy Open Data Hub, which is a blueprint to build AI services on OpenShift. And it provides us with services like Jupyter Hub, Kubeflow, and Superset that we can use to create our AI applications. So we have the cluster set up, we have the Open Data Hub instance deployed on that cluster, and now we can actually move on to replicating the NLP model developed in the community. So next I will move on to the environment setup and give you a demo of how all of this actually works. But before that, I just want to take a pause here and ask if you guys have any questions about the overall goal or Operate First, ODH, OS-Climate communities. If not, I can just go ahead with the demo. So the first part is the environment setup, where we are going to look at the AICOE OCS demo repository. So this is an open source repository that you can use to contribute to this project. And this was generated from the AICOE project template, which is based on the cookie cutter data science platform, which basically is there so that we can use the best practices in the data science open source community. And once we do that, we have a set of files that we can edit and that make sure that our project is well organized. So in this repository, I'm going to go through some of the important files that would help us to create a reproducible set of experiments. The first one is the Pip file. So this file is there for us to add all the requirements that this project would need. So we have packages like Torch or PyTorch, which would help define the NLP model. And then we also have the exact versions here, so that whenever we want to replicate these experiments, we don't have to manually go and fix any version dependencies. So once we have the pip file set, we can go ahead and create the pipfile.log, which would be used by the source to image pipeline that I'm going to talk about next. So the AICOE ci.yaml file is a configuration file for the AICOE CI pipeline. This pipeline is basically responsible for taking the source code in this repository and creating an image out of that, which can be used in OpenShift containers. And that image would have all the dependencies that we listed out in pip file. So the build strategy here is Dockerfile, which means we'll also be using a Dockerfile to create that image. The registry is Kpi.io, which means once the image is created, it'll be automatically pushed to Kpi.io. And yeah, that's pretty much it in this file. Let's go ahead and look at the Docker file that we defined. So this file has the base image that the pipeline would use to create a new image, the environment variables that would be available for that container, and finally some Linux packages that we will need in the image. So once we have specified that, the next thing to do is to create a new release. When we create a new release, in this case, version 0.13.0, the AI/CI pipeline will get triggered, and it will build the image that we want and push it to the Kpi repository. So this is the Kpi repository for OS-Climate org. And here we can see the version 0.13.0 as the latest image that is available on Kpi. So every time we have any changes in the code and our workflow, we can update that on GitHub and then create a new release, and that would be reflected in the Kpi repository. Now, why are we doing all of this, and how are we using this image? So the next step here is to actually go ahead and use the environment that we set up, so which is through the Jupyter Hub application. So this application is provided to us by the ODH deployment, and this is the homepage of that application. So it basically allows data scientists to create notebooks and run their machine learning workloads. So the first configuration here is the notebook image. And right now it's selected, we have selected the AI/CI OS-Climate demo, which is the same image that we showed on the Kpi repository. So it's referring the latest image on the Kpi repository. And we can then select the deployment size or whatever we would need to run the experiments on number of GPUs, and click on Start Server. So this is going to spawn a container for us with all the dependencies that we need. And then we can go ahead and start executing the NLP code. So before I do that, I'm just going to quickly go and talk about the overall NLP architecture. So we have the pre-processing block on the left, where we have text extraction. For simplicity, I'm just going to go over this notebook. So what this means is that the raw PDFs that has climate information, we are going to convert that into text files and save that output back on Ceph S3. So once we have extracted or pre-processed the PDF files, we can then go to the inference step, where infer relevance and infer KPI are two tasks that we have NLP models for. And I'll go over them in detail in a bit. But once we do the inference and have model outputs, we go to the post-processing step, where we have the results table that takes the model inference, converts it into a SQL table, and uses Trino, which is a SQL database engine, to do that. And then finally, we have a visualization dashboard superset that uses that SQL table and basically shows all the results that we got. So this is the overall architecture of the NLP solution. Now we can go ahead and look at that in detail. So the container that we spawned is ready. And if we go to the root of this repository, we see that a folder was created 2 minutes ago. And this folder has all the files that we had in the GitHub repository. So basically what has happened is we have taken all the notebooks and all the dependencies that were listed in that GitHub repository and created this workable instance. So we go to demo 2 and then we can click on all the notebooks that we're interested in and then just start running. So the first one is PDF text extraction. And like I said, it would take raw PDFs on S3, convert it into text, and store the JSON files back on S3. One thing to note here is that to be able to connect to the S3 bucket, we have to have the right credentials. So we have to specify either in the notebook or through the automated pipeline or through a credentials.env file, the S3 endpoint, S3 bucket, S3 access key, and S3 secret key. Once we do that, we can easily connect to the bucket and then have that communication established. So after the results from PDF text extraction phase are saved on the S3, we can go to the Infer relevance step. So Infer relevance step basically takes the extracted text from the PDF text extraction phase, and it takes a bunch of questions that you're interested in. So these questions are called KPIs, and these KPIs are something like, what is the base year of carbon reduction commitment? Or what is the target year for carbon reduction commitment? Or what is the target carbon reduction in percentage? So we are interested in these questions, and we want answers to them without actually reading the PDFs. So this model here takes these questions and all the PDFs, and then tries to find the relevant paragraphs in those PDFs for each of those questions. So let's actually run this notebook and see some of the examples. If we look at prediction on a single example here, the input text is that the company, the input question is the company going to go green? And the input text is the company expects to reduce carbon emissions. Now, the task of the model is to say whether or not this text is relevant to this question or not. So, and we get a label 1, that means this is relevant. And if we just go ahead and take a sentence like, the company expects to generate 1 billion in revenue, and run the same model, it shows a label 0, which means that this sentence is not actually relevant to the question, is the company going to go green? So this is example, this is prediction on a single example, but we can run this for the entire PDF and the collection of PDFs that we are working with. So at the end, we have a table which has PDF name, text, and question, and then also if it's relevant or not. So I'm going to go over the results in a bit, but let's move on to the next step in the Infer phase, which is Kpi Inference. So in the previous step, we had a bunch of questions and they extracted text from PDFs, and we knew that which parts of those PDF are relevant to the question. But now we also want the exact answer to those questions. So for example, for the question, what is the target carbon reduction in percentage? We not only want to know the relevant paragraphs, but we also want to know the exact percentage. So in this step, we take those relevant paragraphs, and from those paragraphs, the model tries to find the exact answer. So I'm going to quickly go and show one of the examples. So here the context is actually from a real example where we take one extract from the PDF about Paris Agreement on climate change. And the question is, what is the target year for climate commitment? When we give that to the model, we get an answer like 2021. And again, this is for a single example, but we can scale it up for the entire PDFs and the collection of PDFs that we have. Finally, we get the results table, and then we store it back on Ceph S3. The final step of this workflow is creating results table or data ingestion. So what this notebook is doing is that it takes the final results from the inference pipeline and then creates an SQL table. So in a sense, what we have done is taken raw PDFs, extracted text, and then inferred using our NLP models. And finally, when we have some structured results, create a structured table in Trino. So at the end of this, we have a table in Trino with columns like PDF name, KPI, KPI ID, answer to that KPI, which page it was found on, what's the relevant paragraph, and so on. We can, towards the end, we check whether if this table is, we can query this table or not. And we see here that we can. So this is basically the workflow. The next important part here is how we take this workflow and convert it into a pipeline and then run it in an automated manner. Before I do that, I again want to pause. If you guys have any questions, I'd be happy to answer them. Nope. Okay. So let's go ahead and talk about the inference pipeline. So like I said, we want to now run all these notebooks in an automated fashion. And we can do that using Elira pipelines. Elira pipelines basically enable us to have a drag top kind of UI where we can put these notebooks in the order we want to execute them automatically. So I can actually go ahead and show how we made this pipeline. So this is the drag and drop UI. We can take PDF text extraction notebook, Infer relevance notebook, Infer KPI notebook, and so on, and then create a link between them that shows the order in which they would be executed. And now each of these notebooks would be run in separate containers. So we have to specify certain properties, and we have already done that in the inference pipeline specified here. So we can go ahead and click on properties and look at some of the configurations. The first one is runtime image. So this is the image that we specified in the query repository. And we have to actually go and create an image like this. So this points to, wait a second. I think this is it, yeah. So this points to the Quay.io OS-Climate image that we created. If we want to create a new one, we can just go ahead and click on the plus button here and specify the endpoint of that image, and it will be created. For now, we just have to select the runtime image for this notebook as AICOCS demo, and select the CPU, GPU, and RAM requirements, select file dependencies, and the environment variables that would be needed to communicate with Ceph S3 for data extraction and then data storing intermediate data. So we have to do the same thing for the rest of the notebooks as well. Quickly do that. Right. So once we have created this pipeline and specified everything that this would need, we just have to specify the Kubeflow runtime where this would be executed in real time. So to do that, we go here and click on the plus button and add a new Kubeflow pipelines runtime. Now this would ask us the name of the pipeline, the endpoint where you want to run this, and also the S3 storage credentials. Once you set this up, you'll have something like this, Kubeflow pipelines with the right endpoint and the right cloud object storage endpoint. Once we have set that up, we just have to click the plus play button here and call it Inference Demo Test. And runtime platform would be Kubeflow. And runtime configuration would be the one that is specified right now. And then we can click on OK. So once we do that, we can check the status of our job here. And we see that we have the first notebook, which is PDF text extraction, being executed here. We can go ahead and click on the logs, and that would show the exact cell in that notebook which is being executed. So, right, so this is going to take a while to get a bunch of PDFs and then run inference on it. But I already have an instance where I ran the experiments. And towards the end, you'll have a screen that looks like this. So you would have PDF text extraction, Infer relevance, Infer KPI, and create results table, and a green tick right next to it, indicating that these ran successfully. So at the end of executing this Kubeflow pipeline, we would have a Trino table. Now this Trino table is something that we can query. And we're going to do that using a superset instance, which is again provided by ODH. So this is what the Superset dashboard looks like. So we have two filters here, KPI and select company name. The KPI are the questions that we're interested in. So let's say, what is the target carbon reduction in percentage? Okay, I see an unexpected error. This should be okay if I refresh it. Right, so let's try it out. Right, so that works. And then we can select from a bunch of PDF names, which are basically from different companies. So we can look at whichever company we are interested in, and we would see the answers to those questions. And we can again like play with this, add more questions to the mix, and look at the answers that the NLP model comes up with. Now, we can also have some wrong answers here because the NLP model is not perfect. But if we look at from the goal where we started, we wanted to have information from PDFs without actually reading hundreds of pages. We have narrowed it down to a few answers. And we are also trying to improve the accuracy of the NLP model. So that is basically it, an end-to-end model. And in summary, we showed how to use ODH tools to create a reproducible cloud-native data science environment that helped us develop notebooks and then create a pipeline that takes raw PDFs from S3, parses them, runs the NLP model, save the results on Trino, and then visualize them using Superset. So I think it was like a packed demo of how you can use ODH and operate first environments and successfully apply that to your existing NLP and ML projects. So that's it. Hopefully you find the information in this talk useful, and I can take any questions now.
I have a quick question.
Mm-hmm.
So, and I'm new into this. So like, what is the usual industry practice? So like, should you be creating functions and then calling those functions? So like for every like extraction, right, you can create a function or class for it and then call it, provide the parameters, and then run your single pipeline. So is that a good industry practice, or you should create different notebooks and then use MLOps to create that kind of pipeline? Like, what would you recommend, and like, what's the industry practice?
So it depends on your use case, first of all. So one of the advantages of having separate notebooks is that, like I showed, that for each notebooks, we specified the runtime image that we used. And sometimes one of your notebooks that is responsible for data collection may not need packages that are required for your running your ML model. So if you have one notebook with all the classes defined in that notebook, and then you run that in one image, then you have basically restricted yourself to use the same image in the same environment. So I think like that basically depends on what your use case is. And this is, I think, a logical separation of different parts of our workflow.
Okay, so it does give you the flexibility of using different environments.
Right.
That makes sense. Yeah. Okay, thank you.
Yeah, I have another point to add to that. I mean, I think definitely it depends on the use case, but I think one benefit to using the pipeline in notebooks is kind of to make it easier on, if you're, as a data scientist, you're already developing in a notebook and you have already the code written, you don't have to take the additional step of like porting it to a Python script or something. You can just use the notebooks that have already been written directly.
Yep. Makes sense. Yep.
I have a question, if I may.
Mm-hmm.
So first of all, thank you for the very nice presentation and all the concepts that were presented here. Very useful and very nice. Did you consider in your plan, I don't know, maybe as a next step or something, like how to actually make all these pipelines run in parallel? Because if you have like many files, you know, then the way I see it right now, it runs in sequence, right? So once for every file. What would you suggest, or if you already have thought about it, on how to expand this experiment in making it to run in parallel for many files, which are basically independent? So independent processing is possible, right?
Right. So that's an interesting question. And I think we have talked about it in the past. One way to do it would be just like have multiple PDF text extraction notebooks and have them run in parallel, and then the results of those notebooks would go to Infer relevance. So that's one way of doing it, but then there can be different architectures around parallelizing it. We have an open source community, and this is something that we would like to work on. So I would encourage you to create issues and talk about this in the open source environment. And there would be experts, Eric, Michael, Karan, Ian, everyone who would contribute to that discussion.
Okay, thank you.
Awesome. Thank you so much, Shrey, for giving this wonderful presentation. If you all have any questions, this would be a good time to ask Shrey. And any suggestions, feedback for Shrey, please feel free to reach out to us. And thank you everyone for attending this Operate First Community Data Science Meetup. And we hope to see you all in our next meetup, which is on February 22nd. And take care, you all, till then.